morning, AP Chemistry. Cheers to you. Let's get started, get a little caffeine going. This is just going to be a little quick tutorial on the calculations for the lab that we did on Monday and Tuesday. You have the lab sheet that has the calculations all on it for you. And so I just kind of want to go through there. Now, on the board right here from last week, we have the steps on calculating the empirical formula just of a compound from percent composition. And so you would change, you take the percent, you change it to grams. This is from the worksheet that we had. We just change it to grams and then change grams to moles for each element. And then you divide by the smallest to get a whole number ratio. Now, when you're dealing with a hydrate, okay, when you're dealing with a hydrate, and just here, just when we get the molecular, once we have the empirical formula, to get the molecular formula, we just get the empirical formula mass, divide it in, and do this. We didn't really have to do this part for the lab. So I'm going to erase this. But in the lab, we had a hydrate. Now, I'm not going to use, well, for instance, you had CuSO4.XH2O. So the first thing that you need to do is, for part A, is you're going to calculate what that value of X is. Now, this is an understood 1 right there. So it's going to be a 1 to 1, 1 to 2, 1 to 3. This X is going to be a whole number, but it's going to be 1 mole of this compared to X moles of that. So we need to figure out how many moles. Well, we measured, you have the mass of the evaporating dish. You have the mass of the evaporating dish plus the contents. Then you have the mass of the evaporating dish after heating. Now again, for those full-time virtuals, we heated what we said we called it, we heated to a constant mass. So we had to heat it for 10 minutes, then we let it cool, heated it, waited, heated it for another 2 minutes, let it cool, and waited again. These two masses needed to be really close to one another. That's the only way we know that all the water has been gone, has been eliminated, okay? And so, if you, of your two values, use the lower value, okay? Use the lower value. Of the two heatings. Okay? So if they're off by 0.01, 0.02, use the one that's lower as the mass of the evaporating dish and contents after heating. Now, given this, how much it was at the beginning, how much it was here, knowing that this is going to CuSO4 plus XH2O, but this is coming off as a gas, this is staying behind. So, using this data, you should be able to calculate the mass of the copper sulfate and the mass of the water that was released. Once you have the masses, change that to moles of this, using the whole molar mass of that and the molar mass of water. Convert to moles, divide by the smallest, and that'll give you your whole number ratio. Now, I use the example of calcium chloride .2H2O. Calcium chloride dihydrate, okay? Calcium chloride dihydrate. So whatever that number is, we're going to use the prefix mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay? And so in this one, let's just say you go through and do these calculations and you find X is equal to 2.11. Well, the nearest whole number is 2, so you would say that your X value is equal to 2. But however far away you are from that whole number is going to be your error. And so if you recall, I don't know if you can see over on that side of the board or not. If you recall, percent error is equal to your measured or your calculated value minus the correct value, the right answer, divided by the correct value times 100. So in this case, your measured value is 2.11. Your correct value is 2 divided by 2, so your 0.11 divided by 2 is going to be your percent error. Now obviously it's times 100 to put it into percent. So you need to go through for both of your two trials. So on your calculations, label it trial 1, okay? And then you can just go through and calculate the mass of each, convert the grams to moles, and then find your mole value. Do that twice for each trial, okay? Calculate your percent error twice. See which one, see if any trial was better than the other trial, okay? So that's all you have to do for part A, the empirical formula. Find your grams of each thing, okay? So we have the copper sulfate dot XH2O going to CuSO4 plus XH2O. But this is a gas, this is a solid, this was the solid. So you're going to get grams of this from your data. You should be able to calculate grams of this, grams of that, convert to moles, divide by the smallest, you get your value of X. Calculate the percent error. You do that twice. Then, for part 2, percent oxygen. The KClO3 solid, when we heated that up, and the triangle over the arrow means heat, when we heated that up, it went to KCl solid plus oxygen gas. Balance the equation, a 2 and a 2. Now we don't really need it on that. Now we know that we used approximately 2 grams. Now you need to use whatever value you measured is what you should get. Now again, you can calculate this from your data table, how much was actually in your crucible, okay? Then we heated it up, and because this is a gas, it was given off. So obviously the mass went down. So from your data again, you can calculate the mass of the KCl and the mass of the oxygen gas. Now we want percent oxygen. So that's going to be mass of oxygen divided by the total mass of your sample. That's this value, whatever you got, times 100. Okay? Now, that's all you have to do here. So then, you should do this 2 times. You're supposed to have copied the data from somebody else in the class. So you should have 2, so do it twice. Calculate this is your experimental or your calculated value. This is the calculated value. Okay, it's going to give you this. Now, your theoretical value or the right answer, this is like the problems you just did on the worksheet. We know it's KClO3. Well, from the formula KClO3, we should be able to determine the percent oxygen, mass of oxygen over the total mass, molar mass. Okay, so show the theoretical value, calculate it, just doing the math like from the worksheet, like we did in class, like this. Well, actually, it's not like this, it's like we did before this, the percent oxygen, okay? That's your theoretical value. Then on your percent error, you need to again do it twice. Your percent error, this is your calculated value, this is the correct value, divided by the correct value times 100, okay? So, From the data, you calculate how much the mass of this and the mass of this. We're only really concerned about the mass of this one, divided by whatever you started with, the total mass, times 100. Do that twice for each of your 2 trials. Calculate the theoretical value. You only have to do that one time. That's not going to change. And then do your percent error twice, once for each trial. Be sure to label it, use units on everything, and use sig figs. Okay, so when you're doing the percent error, remember subtract and then divide. And so I'm going to look at all of those things. Okay. Now, if you have any other questions, feel free to email me, or you can contact me through Remind. Either way, and I'll be glad to answer any questions that you might be having if this is not clear for you as far as what you should do. Now, once you finish your calculations, you're going to need to answer the post-lab questions. Just make a whole new section. So in your, and on the classroom, for the virtual kids, I kind of gave a format of what you're going to do. And you should already have the title, the purpose, you have your data for part 1, observations for part 1, data for part 2, observations for part 2. Then go and put the next category, calculations. Then you go part 1, empirical formula of a hydrate. And then do all your calculations for part 1. On the sheet it says part A. Then do part B, calculations. Show all the work on the calculation we just talked about. And then after all your calculations are done, you can just do a heading questions. And then you do not have to write the questions down, but just go answer the questions. 1 through 5 should be complete sentences. 6 and 7 just is the name and the formula, so you can kind of go from there. All right, again, if you have any questions, email me, let me know.